I'm not sure this is going to be a beautiful lecture, but at least you'll learn some biology in it. It's about why evolution is true. And before I start, let me ask you a question. You can just raise your hand and answer. How many of you accept that evolution is true? Okay, so that's almost all of you. I won't single out anybody that doesn't. Second of all, how many of you accept that because you know the evidence for evolution, as opposed to just believing that your teachers are true? So if you know the evidence, raise your hand. So, okay, so that's about a third or less. So that at least I'll have a function here tonight, because that's one of the things I'm going to do, is to give you the evidence. And how many of you think you could, in a debate with a creationist, and those are the last group, how many of you think you could win in a debate about creationism versus evolution? Okay, 2 or 3. You're brave souls, actually, because they have rhetorical tricks that are very... Okay, so what I'm going to do is equip you, maybe not necessarily to debate with the creationist. This microphone is working, right? Not necessarily to debate a creationist, but at least so you will know the evidence for evolution instead of just having to take it, I hate to use the words on faith, but let's say on the authority of your teachers. But let me also say that the opposition to evolution is not based on ignorance. People do not reject evolution. They're not creationists because they don't know the facts. They reject it because of tribalism. This is a statement from Steven Pinker's latest book, Enlightenment Now. Possessing a belief in evolution is not a gift of scientific literature, but an affirmation of loyalty to a liberal secular subculture. That is, if you do a survey of how much people know about science, and then ask them how much they know about evolution, the knowledge of evolution does not correlate with any other knowledge about science. Rather, it correlates with how religious you are, or how politically liberal or conservative you are. So for most people, accepting or rejecting evolution is not based on facts at all. It's based on showing your adherence to a certain group of religious group. In the United States, it would be extreme religious people or Republicans in general, but in other countries, it's other different. So to some extent, what I'm going to talk about today, which is in my book, Why Evolution is True, is not necessarily the best way to change people's minds. And I talked a little bit last night on how a better way to change people's minds might be, which is to dispel the kind of religious belief that objects to evolution. I'll talk a little bit about that today, but this talk is mostly about science. Okay, so why is it important that we understand evolution and also to accept it? First of all, I consider it the supreme intellectual achievement of human beings, to be able to figure out where we came from. This peculiar recursion, where this blob of jelly in your head has been able, through rational inquiry and scientific understanding, to understand how it works, or where it came from in the first place. And that's a pretty remarkable achievement. Second of all, and there's lots of reasons, it shows the ultimate ancestry not just of the human species, but of every species that ever lived. So if you're into genealogies, like your own family tree, well, that's trivial compared to the genealogy of life, which is revealed by evolution, and it is approaching the true genealogy of life. Second of all, it involves comparing explanations. So what I'm going to do today is give you 2 competing explanations for the phenomena that we see on Earth, life. One of them is creationism, which is the main opponent of evolution, the biblical or religious story of evolution, of life, versus the scientific story. And teaching it this way is a good way to teach you how to use evidence to decide between competing viewpoints. Of course, evolution wins because it's true. It's a way to show you that the naturalistic approach to understanding life, as opposed to supernaturalism, that is, invoking divine beings or gods, is really the only way to understand the phenomena of science. And that's what I talked about last night in my lecture. The evidence is diverse and amazing. This is one of the reasons I like to give this lecture. This is a revision of a lecture I give to my first class in evolutionary biology to help them realize how much understanding evolution can bring to the study of biology. It has important effects on our self-image. If you study evolution, you're going to think of yourself in a different way than you would, for example, if you believe in the Genesis 1 and 2 stories. You're going to realize, for example, that we're not anything special. We're just highly cerebralized primates. in principle, no different from squirrels or groundhogs or alligators or dandelions for that matter. And finally, it's a vital part of any biological explanation. A very famous statement is, nothing in biology makes sense except in the light of evolution. Well, that's not exactly true. There's lots of things in biology you can study without knowing evolution, but the ultimate explanation for all phenomena in biology, why is it there? How did it get there in the first place? Requires you to understand evolutionary biology. So these are all the reasons why it's important to understand evolution. And the main reason, which is important in almost every country, but particularly in the United States, and I gather somewhat in Croatia, it gives you a respect for scientific evidence. If you have two opposing points of view, and in my country, evolution and creationism are really opposing points of view, the way to settle that is not through faith, it's not through assertion, it's through appeal to the evidence, which is the way science works, and today I'm going to give you some of that evidence. Let me show you how bad things are in my own country. It's not quite as bad in your country, although it's not perfect, and as I'll show you. If you survey all of Americans and ask them how they think life got here, and especially human beings, because humans are the hard case for evolution. There's lots of people that think that everything evolved except humans, for obvious reasons. And you ask them how people got here, you give them three choices. First of all, we evolve from earlier species? That's the strict Darwinian naturalistic explanation of evolution. Second of all, the alternative, human beings were created directly by God in the last 10,000 years. That is the young earth creationist explanation. And it comes straight out of the first two books of Genesis, but also it's believed by Muslims and Hindus and many other religious people as well. Finally, there's what we call theistic evolution, that humans did evolve, but God inserted his, her, its hand into the process at certain points to guide it in certain directions, make certain mutations, or tweak the process. Okay, so you give Americans those three choices, and this is the answers you get. 38% of them are young earth creationists. That's nearly 4 out of 10. 38% of them are theistic evolutionists. That is, they sort of accept evolution, but not quite in the way that scientists do. And 5% of them don't know or are unsure. Now you can do the subtraction. What's left in terms of naturalistic evolution? Well, first of all, 76% of people think God had some role in evolutionary biology in the process. That leaves 19%, or 1 out of 5 Americans accepts evolution the way I teach it to my class, and presumably the way it's taught at the University of Zagreb, presumably the way it's taught in the public schools of Croatia, although I'm not sure about that. So that's pretty dire. And those are the statistics. I don't know if you can see them that well, but the top, this is over the last 34 years. They ask this question every year or two to Americans, and you can see the answers are pretty constant over time. About 40% of Americans are creationists, young earth creationists. Another about 40% are theistic evolutionists. That's the middle line. And the bottom line are the scientists, the Darwinists, those who accept naturalistic evolution. It's been going up. It used to be 9% in the 80s, and now it's 19%. So that's almost doubled, but still, it's not up to 1 in 5 yet. And over this time, this has been the time of the great popularization of evolution by people like Richard Dawkins, David Attenborough, Stephen Jay Gould, people like Bill Nye, Neil deGrasse Tyson, Carl Sagan. All this has been this 34 years that these people have been preaching evolution. But the lines haven't moved, which shows you that it's not necessarily that learning about evolution or popularizing it is the way to make people accept it, because these lines they don't move over time very much. Now, why is that? In the face of all the new evidence we have for evolution, and some of that I'll give you tonight, and in the face of all these famous people that write books and do television shows about evolution, why don't those lines move upwards? I'm talking about the bottom one now, and the top two lines, why don't they move downwards? Well, the answer is religion. So these are 34 first world countries which are ranked in terms of their acceptance of evolution. The blue lines are the proportion of the people in each country that accept evolution. The yellow bars are those who don't know, who waffle, and the red bars are the percentage of people who reject evolution, who are presumably creationists. Okay, and now I'll put the United States there out of these 34 countries. We're next to the bottom. The figures are a little bit higher than the ones I gave you before because the polls vary in what they say. But as you can see, we're next to the bottom. The only country below us in these 34 countries is Turkey, which is a Muslim country. And Turkey has just banned the teaching of evolution in its public secondary schools because of religion. So it's still allowed to be taught in college, but not. Okay, so where's Croatia here? It's one of these countries. And there it is, with about 44% of Croatians accepting evolution. So if you guys think you're really good, well, you're better than Americans are, but you're still less than half, right? So there's still room for improvement here. You're in the lower half, so you can be proud in that you're better than Americans. In fact, most people are better than Americans. But you're not as good as the Icelandic, Denmark, Sweden, France, Japan. You can notice that the countries at the top are Scandinavian and Northern European countries. And if you think about, well, why this ranking, you come to realize that there's a correlation between how religious a country is and how accepting it is of evolution. The countries at the top, the evolution acceptors, are in general the least religious countries in Europe. Sweden, Denmark, Norway, and Iceland are almost atheistic countries. The countries at the bottom, the United States, Turkey, Cyprus, Latvia, Lithuania, Bulgaria, Greece, those are countries which are religious. And in order to show this to you a little bit more clearly, I've just plotted on a graph the religiosity of various countries. These are 32 European countries. And the religiosity is plotted on the x-axis, so the most religious countries are over to the right, least religious to the left, and then the acceptance of evolution is on the y-axis. Okay, and you can see there's a downward slope to these countries. In fact, if you did a statistical analysis, you'd find that this is a highly significant relationship. If we plotted other countries, for example, those in sub-Saharan Africa or in the Middle East, you get a bunch of points over here, because those countries are not only very religious, but they're also great deniers of evolution. So the graph is even more pronounced than you see here, okay? What we see here, if you're an economist, you'd call this an inelastic demand curve for God. That is, you would have to give up 40% of your belief in God in order to gain 10% more belief in Darwin. So that's how bad it is. Now, why do we have this relationship? Why is it that the countries that are most religious, these ones over here with the bigger God symbol, tend to believe in evolution less or accept evolution less, and the countries that are more atheistic tend to accept evolution more? Well, this is a correlation, it's not a causation. There's several possible explanations, one of which is if you're highly religious, you tend to reject evolution, okay, because it goes against certain aspects of your belief system, as I was talking about last night. The other explanation is if you accept evolution more, if you're more scientifically aware, then you tend to reject God more. So those are two competing explanations, and I think they're both partially correct, and there's also another explanation, which is poverty, which correlates with high religiousness and low acceptance of evolution, but we won't talk about that now. But I think the main explanation is that the more you believe in God, because of the cultural history, your own indoctrination as a child, the less likely you are to accept evolution. And that's why countries that are the most religious countries are the ones that accept evolution the least. Okay. Now, where's the United States here? There we are. Again, second from the lowest. That's Turkey over there at the lower right. Where's Croatia? Well, I have two figures for Croatia. This is the one that came with this original data, and you can see it accepts evolution more than Americans, about 44%, and it is less religious, about, I think, 55% in this data. But then the journalist Nenad gave me his own figures that were taken from more recent surveys of this country, which puts Croatia there. More religious than America, with 86% of the inhabitants of this country accepting God, and about 41% accepting evolution. So you're still better than America in terms of scientific acceptance, but not that much, but you're more religious. Now, who knows? I mean, what does it mean to be religious? If you say you believe in God, but you don't go to church, or you just say it because you think the surveyor wants to hear it, who knows? So I put both figures up for Croatia because it's not clear where you lie. But you're certainly not up there with Norway, Sweden, Denmark, or Iceland, or Switzerland. So I hope this lecture may have some effect, although I suspect from the first question I asked that most of you accept evolution anyway. The fact that religion immunizes people against evolution is evidenced by the fact that every creationist organization that I know of and every single creationist I've ever met has opposed evolution because they're religious. Okay? That supports the first explanation, that religion immunizes you against evolution rather than evolution immunizing you against religion. So here's some of the creationist organizations in the United States, and you can see they have the word ministry, reasons to believe, answers in Genesis, creationism, etc. It shows you that these anti-evolution organizations are basically religiously motivated. Even intelligent design, which is an upgraded form of creationism, it's called creationism in a cheap tuxedo. That's why I have the bow tie there. But it's basically creationism. Intelligent design is also motivated by religious backgrounds. And the people that push intelligent design, if you scratch them, you'll find a priest underneath, or at least a believer. Okay? And this is more evidence for the fact that the opposition to evolution is based not on ignorance of the facts, but based on the embracing of some other point of view which is inimical to evolution. Okay, so that's why I wrote this book. I wrote this book in 2009, hoping, with the evidence for evolution, and it's been translated into Croatian, I'm hoping that Americans would change their mind, that 19% of Darwinists would rise up to maybe 80% or 90%. Well, of course, that was a foolish hope, because at the time I didn't realize that opposition to evolution was not based on ignorance, but based on religion. So although I wrote this book and it did change quite a few minds, it didn't cause a sea change in America where everybody suddenly became a Darwin lover. But anyway, I'm going to tell you what's in the book and what's the evidence for evolution. And if you already accept it, at least you'll know what the evidence is. And the next time a Jehovah's Witness comes to your house to talk to you about creation and try to convince you, you'll at least have some ammunition to use against them. And you can buy this book. It's been translated into Croatian with help from Pavel. Okay, so what I'm going to do is, for the rest of this talk, give you the evidence for evolution. Okay, first of all, I have to tell you what evolution is, because it's more than one thing. I have to tell you what a theory is, because it's called the theory of evolution, and that's often used to denigrate it. It's just a theory, it's not a fact. And then I have to tell you what we mean by true in science, and I'll try to do this very briefly. Okay? So evolution is called a theory, the theory of evolution, but a theory is not just a wild speculation or a wild guess, like Donald Trump is going to bomb North Korea. That's a wild well, it's not that wild, actually. But it's not just a speculation without evidence. A theory is a set of propositions that's well supported by evidence in science. So it makes sense of a lot of disparate facts, and it is well supported. Here's some theories that are also facts. So the atomic theory, that's the view that the smallest constituent of matter that retains its chemical properties of an element is an atom. That's called the atomic theory. But of course, all of you believe in atoms. You don't say, well, atoms are only a theory, so I'm going to reject it, right? Because everybody, we've even seen atoms under an tunneling electron microscope. The germ theory of disease, that infectious diseases are caused by bacteria or viruses. That's called a theory too, but it's also true. So a theory can be true. And the last theory is the theory of evolution. And I will maintain and try to show to you this evening that evolution is just as true as the theory of atoms and the theory of infectious diseases. So you can't just dismiss evolution, as many people do, by saying it's only a theory. Ronald Reagan said this in 1980. Well, it's only a theory. And, you know, there's some people who don't like it. You know, I mean, that's appealing to the person who doesn't know what a theory is. So the theory of evolution is just as true as these things. What do we mean by true? Well, what we mean, and this is Steve Gould's definition of truth in science, it's an assertion for which there is so much evidence that it would be perverse to deny it. Okay? In other words, you would be considered irrational if you denied, for example, the existence of atoms, or the fact that flu is caused by a virus. And you would be just as irrational if you denied that evolution, as I will describe it to you in a second, is true. We don't have a concept of absolute truth in science. Anything that we find out to be true can always be provisional, but I will try to convince you that as true as anything can be, as true as atoms are, as true as microbes are that cause flu, evolution is true in exactly those same ways, and it is unlikely to be overturned. I will give you, near the end of this talk, a list of evidence that would show evolution to be false. Okay? It can conceivably be disproven, but it hasn't been, and I would bet every penny I own that it won't be. Just like I would bet every penny I own that the formula for a water molecule is H2O. That's how sure we are about evolution. Okay, so what is evolution? It's not just one thing. I think of evolution as being 5 separate assertions that have to be taken together, at least the modern theory of evolution. The first of all is that evolution happens. And by evolution, I mean populations change genetically over time. A population is the entity that changes from one generation to the next, not the individual. Evolution means genetic change over time. Second of all, that change is gradual. And by gradual, I mean it doesn't happen within 1 year or 1 generation in general. Okay, evolution, particularly substantial evolution, like the evolution of fish into amphibians, takes millions of years. Lesser evolution, like us from our ancestor with the chimpanzee, took about 6 million years. So it's slow. Third of all, there's the process of speciation, or splitting, which is my area of expertise. That is, you don't just have one population or one lineage changing over time. You have lineages splitting into other lineages. And this is how, starting with the single original species, probably about 3.8 billion years ago, we get the tree of life, which is so complicated now that we can't even represent it as a tree. We have to represent it as sort of this circle here. That's the original species in the middle, and then we have some of the species around the edges, but we probably have anywhere between 5 and 20 million species on this planet today. They all came from an original species by this process of branching and branching and branching and branching. Some of the branches, of course, get pruned off, and that's called extinction. So this is point 3 of what evolution is. Point 4 is basically the same thing as point 3, but looking at it backwards. That is, if there is a tree of life with branches, then you could take any 2 branches anywhere on the tree and find a common node where they meet. That is, every pair of species on this planet, no matter what it is, has a common ancestor sometime in the past. This is basically the same thing as the assertion I just made, but looking at it in retrospect instead of looking forwards. Okay, that's point number 4. And for example, this is the family tree of primates. There's us and our common ancestor with the chimpanzees. That's about 6 million years ago. Our common ancestor with the gorillas, that's about 9 million years ago. Our common ancestor with the orangutans, about 15 million years ago. And so on and so on and so on. I could put every species on Earth on this graph, but some of them would be way over here because they're distantly related. But any 2 species, you can find a pathway that connects them genetically. So that's point number 4. It's the same thing as number 3. And finally, and this is Darwin's great intervention, that the evolutionary change that results in adaptation, that is, the remarkable features of plants and animals that make them look suited to their environment, is caused by the process called natural selection. There are other things that will make species evolve besides natural selection, but natural selection is the only force we know of, the only pressure that will make organisms look as though they were suited to their environment. That will give the woodpecker its remarkable beak and its feet to hold onto the trees, that will give the cactus its spine, that will give the camel its hump. So these are the 5 parts of the theory of evolution as I see them. And if you want to prove that evolution is true, you have to substantiate every single one of them, not just one of them. It could, for example, be true that evolution has occurred, but natural selection wasn't the process that did it. Or that evolution could occur, but you don't have the splitting process. Or that evolution could occur, but it's not gradual, it's instantaneous. So in order to substantiate what I call the theory of evolution, we have to actually buttress all these 5 points. And for the rest of this lecture, I'm going to give you that evidence. And at the end of it, I hope you'll see that every single one of these assertions is supported by evidence. Okay, let's start very simply. Evolution makes predictions. Obviously, the Earth started off hot. Then it cooled off, and there must have been a single original ancestral form of life. We also know this because there are features of all life which point to a single species from which we're all descended, which probably lived somewhere about 4 billion years ago or even earlier. The predictions are that if you look in the fossil record, or you go back to the earliest strata deposited on Earth, you will find simple organisms at the beginning. And only later, after millions and billions of years have passed, do we get the buildup through natural selection of more complex organisms. That does not mean that evolution is a march from simplicity to complexity. It just means that it has to start with simplicity, and complexity can only come later. But you can still have simplicity later. After all, we still have viruses and bacteria with us. And in fact, okay, so that's what I just told you. And this is exactly what you see if you look at the fossil record. Here's a view of the fossil record starting at about 4.6 billion years ago when the Earth cooled off and was created up to the present time. And on the right, you see when organisms first appeared. So we first see life at about 3.8 billion years ago. Very simple organisms. They're blue-green algae, better known as cyanobacteria, photosynthetic bacteria. And then we see shelly animals and worms, and then later fish and land plants. And you see that the average complexity increases over time. But of course, we still have simple organisms up at the top. It's just that you have to start simple, and then you get more complex on average over time, which is exactly what evolution predicts. This, by the way, is the earliest form of life we know of. You can see it at the Neanderthal Museum in Krapina. They have a slice of this. This is stromatolite. It's layers of blue-green algae or cyanobacteria that build up in saline waters, one on top of each other. And it's indubitable evidence for life existing 3.8 billion years ago. But it's still here, because we still have stromatolites. You can find them in Shark Bay in Australia. Here's some of them forming right now. So this doesn't mean that the earliest forms of life have disappeared completely. They just gave rise to other forms of life through branching, but their descendants are still with us. And if you go to this remote part of Australia, you can actually see what life looked like at the very beginning. So this is one prediction that evolution makes that is justified. Let me say that in the argumentative form, creationism does not predict this. If you read the Bible, you will predict that you will see all of the animals and plants originating at the same time in the fossil record because God made them in 7 days. Or if a day is taken metaphorically to be 1,000,000 years, still the order of creation is different from the order given in the Bible. So you can't justify any form of biblically based creationism from this fossil record. Okay? Another prediction. So we've shown that one prediction. Another prediction is if you look at a lineage, you should be able to find it changing over time in the fossil record, as evolution predicts. Now, evolution doesn't predict that everything's going to evolve, but it does predict that those things that have evolved, you should be able to find them changing over time gradually in the fossil record. And sometimes we should be able to see them splitting as well, because that's part 2 of evolution. Part 3, evolution, gradualism, and speciation or splitting. And of course, this is what you see. There's millions of examples. I'll just give you one. This is the evolution of the horse, which evolved in North America over a period of 55 million years. And these are horses over 55 million years. They start off with Hyracotherium, once known as Eohippus, the Don horse. It's about 40 centimeters tall, about this big. Very small animal, doesn't look like a horse. It has 4 toes. And it's sort of deer-like. And then as we go up in the fossil record towards modern times, because this is the time scale on the left, from 55 million years ago to the present, we see various evolutionary change. We see that the horses get bigger and bigger and bigger, from 40 centimeters to the modern horse that we see today. We see that their toes disappear. The original horse has 4 toes, and then the 2 outer toes disappear, and then we're left with a single toe. I hope this isn't an obscene gesture in Croatian. If I turn my hand around, it would be an American. But you're left with a single toe, which is the hoof. And you can see that change right there. So a horse is actually walking on its middle toe, and the remnants are still left on the sides. I'll show you this in a minute. And you can trace a single lineage that shows this change. So here we see the first prediction of evolution, genetic change in a single lineage. And we see gradualism, because it took 55 million years for this to take place. But we also see speciation and splitting, because there are many lineages of horses that formed and then went extinct. There are some of them right there. So that we see one, and of course they had common ancestors, like right there, any of those branch points. So we see points 1, 2, 3, and 4 already demonstrated in the fossil record of horses. We have a really good fossil record of horses in North America. As for point 5, well, you could say this demonstrates it as well, because what was going on when this was happening? What was going on in North America was that it used to be covered with forest, And then the forests disappeared as the weather became drier and was replaced by grasslands. And as any morphologist will tell you, if you live on grasslands, you need stronger teeth to eat that grass because it wears your teeth down very rapidly. Grass is very high in silicon, so you need bigger teeth. And you also, it's easier to run fast away from predators if you run on a single toe, a hoof, as opposed to 5 toes, which are good for getting away from animals in the forest. So if you watch a cheetah, for example, which has toes, it doesn't run in a straight line. It's always going like this after its prey, whereas its prey is pretty much running straight. So we have a pretty good idea that natural selection is actually, in fact, the cause of this evolution. So in this one graph, we could actually see all 5 points of evolution demonstrated at once. But I'm going to go on, of course, because this is only one example. By the way, some horses, their developmental program, which still contains the genes for toes, but they've been killed off by mutations, sometimes those genes will be reactivated, and you'll find a horse, like this one, which has the extra toes appearing. So this one has 3. Alexander the Great's horse, Bucephalus, I think, was supposedly one of these extra-toed horses. And you can see that the genes that make these extra toes are exactly the same genes that make the fingers and toes in other animals that have 5 digits. Okay. Here's one of the greatest examples of human evolution. You can just go to the Natural History Museum in Zagreb and see this for yourself. This is our own lineage, Homo sapiens. That's a chimpanzee. That's modern Homo sapiens at the lower right. And then all the skulls are arrayed in temporal order, just in order of when they were found. And you can see that an example of gradual change over time. The skull gets bigger. It's very small. I mean, this is Australopithecus right there at the number B. Modern humans here. Neanderthals, I believe, are right there. And you can see that we have a gradual change. The skull gets bigger, the teeth get smaller, the chin forms, the brow ridges disappear. When you show this to a creationist, or especially if you line up replicas of the skull and say, okay, tell me what this means, they get dumbfounded. They cannot explain this. This is some of the most irrefutable evidence for evolution that we know of, and especially convincing because it's our own lineage. Right? Creationists will say, well, this is a guy that had rickets, you know, or he was arthritic or something like that. But everybody back then must have had arthritis for some reason. And then the population gradually got less arthritic as it went on. I mean, their explanation for this simply doesn't make sense. Okay? So again, we have 2 explanations for the data, but only one of them is really a credible explanation. And this is the so-called family tree of humans. It's very unclear because we don't have enough fossils yet to determine the lineage. But here we do see gradual change in a lineage. This is probably one lineage right there, going through Homo erectus. But then there are lots of hominins, relatives of ours, that went extinct without leaving any descendants. So here we see gradual change over millions of years. We see common ancestry, we see splitting, and we see extinction. As for what the natural selection was that caused this process, I'm not going to even dare to open my mouth about that because anthropologists argue very vociferously about that. So, question mark about this, but there's no doubt that we evolved from ancestors with chimpanzees that were pretty much like chimpanzees. We are the naked ape. We are the odd primate out in the family tree of hominins. Okay, another prediction. If there is common ancestry and every 2 species, every pair of species has a common ancestry, we should be able to find the transitional forms between different forms of life. That is, and let me just use one example here. This example was started by Thomas Henry Huxley in the time of Darwin. Huxley, who was a morphologist, observed that there were certain similarities between birds and reptiles. They both lay eggs, for example. Birds sort of have scaly patches on their legs. There are certain similarities in their circulatory system. Before we had a good fossil record, Huxley hypothesized that birds evolved from reptiles, because we knew we had reptiles in the early fossil record. We hadn't found any birds yet, but he hypothesized that these birds came from reptiles. So this is a scientific hypothesis based on evolution. So how do we test this? Well, people will say we look for the missing link. That is the one species, and there has to be one species, that gave rise to all the modern reptiles on one hand and all the modern birds on the other. And this, we now lived at about 280 million years ago. But it was a reptile. It was probably a theropod dinosaur. And the theropod, there was one species of dinosaur that gave rise to all the birds, and then, on the other hand, gave rise to the modern reptiles. However, that's only a single species. So how do you find this thing? Because if you want to show this common ancestry, don't you need to find this common ancestor? And the answer is no, you don't. And it's a good thing, too, because the chance of finding a given species in the fossil record is very low. Paleontologists tell us that only between 1 in 1,000 and 1 in 100 species that ever lived are known to us as fossils. So the chance of even finding a fossil, the rest of them have disappeared, they weren't fossilized, they've been ground up by the churning of the Earth's crust. The chance of finding this common ancestor is 0, pretty much. Does this mean then that we can't prove common ancestry? And the answer is no, because there's other ways to do this. What you do is you start with the modern birds and you dig deeper and deeper and deeper, and as you do that and you look at the fossils, you should find that they get more and more reptile-like as time goes on, okay? In other words, you should find transitional forms as you go further and further back in time. This is another way to prove common ancestry, and this we're able to do because you don't need just that single fossil to do it. Now, creationists say, what would that transitional form look like? This slide I've seen so many times given by creationists to make fun of evolutionary biologists. They say, those stupid evolutionists, they think that birds evolved from reptiles. Well, how would it have happened? You would have had to have something like this, okay? This is what's known as a crocoduck, and it's half reptile, half bird. Of course, this thing is manifestly ridiculous. You don't see these things. It's a croc of something, but it's not a croc of duck. This is not a good transitional form between birds and reptiles, but we do have one. I'll show you a real crocoduck. This is the species. It's called Signathosaurus millenniae. It lived about 125 million years ago, and it is basically a reptile that has some bird-like features on it, okay? First of all, the skeleton is very reptilian. It looks very much like the skeleton of a theropod dinosaur. You can see it has features that are not at all bird-like. It has a long bony tail. You won't find a long bony tail on your chicken or duck. It's disappeared. It has teeth. If you look in the jaw, you might be able to make out teeth. Well, birds don't have teeth anymore, but dinosaurs did. And it has separate fingers in its hand. If you look at your chicken or your turkey, you will find they're fused together. They look like this. So this thing looks very much like a dinosaur, and some of these fossils were misidentified as dinosaurs because they are so close to being dinosaurs. The thing about this one, however, is that it has feathers. And you can see that this is one of these rare Chinese fossils that have the imprints of feathers. You can see them on the hand, you can see them there, you can see them along the tail. What we have here is a feathered reptile, okay? And this is a transitional form. It has features of both modern birds and ancient reptiles together. More than that, it lived at about exactly the right time, 125 million years ago. Birds are thought to have branched off from dinosaurs at 280 million years ago. We see the first modern birds at 80 million years ago. So if there's going to be a transitional form, it has to be between 280 million years and 80 million years. And when you date this using various dating methods, you find, lo and behold, it's 125 million years ago. So it's exactly where it needs to be a good transitional form. If this thing were, say, 400 or 500 billion years old, or 40 million years old, it would be a puzzle. But we don't see that kind of stuff. We find the transitional forms exactly where they should be in the fossil record. So this is another thorn under the creationist's shoe. Okay? That's what it looked like, by the way, as far as the reconstruction goes. You can even tell what color some of these transitional forms are. It probably was unable to fly. Feathers that probably did not evolve to help an animal fly. They probably evolved for thermoregulatory purposes, like having a down jacket, or perhaps for sexual attraction of the other species. Only later were feathers co-opted evolutionarily to enable these things to fly. Okay, I don't know if you can see this very well. Let me turn the lights off. Okay, just for a sec. There you go. Okay, so this is, maybe we should just leave them off. You don't need to see me. I'm not that pretty anyway. This is Basilosaurus. Scientists know that whales are a secondary invasion of the sea from animals that lived on land, like deer or hippos. And they evolved over a period of 40 million years, starting about 50 million years ago. And about 40 million years ago, we find, oh, good, the laser pointer works. Okay, that's perfect. Basilosaurus, this is a 40 million year old whale. Okay, it's about 15 meters long. It looks pretty whale-like. You can see these front paddles here, which are the remnants. I mean, they evolved from, that's perfect. They evolved from the front legs. But if you look towards the rear, look at those things. Those are 30 centimeters long. What are they? Why do these ancestral whales, because these are fully marine organisms, have these things? Let's make them bigger. That's what they look like. Okay, 30 centimeters, so it's like this, right? And a whale that's 15 meters long. These are, of course, the remnants of the rear legs that this animal's ancestors had before it went back to the sea. And you can see every bone in this thing is present in modern humans. There's the humerus, the tibia, the fibula, and the femur of the rear legs. And you can see even the toe bones, but it's only that big. This thing could not possibly have been of any use to a swimming organism at all. It probably didn't even stick outside of the body, but nevertheless, there it is. So why is it there? Creationists cannot explain this, but evolutionists can, because this is a whale in the process of evolving the loss of its legs from an animal that used to have legs when it was terrestrial. And so this, although you might not predict this, it certainly only makes sense in light of evolution. So you can see the analogy between the femur, the tibia, and the fibula. That's our leg, and the same features in the whale leg. And that's probably what the ancestor of the whale looked like. It's called Indohyus. It was probably a deer-like organism that had the ability to swim and has certain features of the ear that make it like a good ancestor for the whale. By the way, does anybody know what the closest living animal on Earth is to the whales? The hippo, right. Hippos are pretty close to whales. In fact, if we stayed around for like 20 million years and watched hippopotamus, it might evolve into something like a whale, because the young can swim before they can walk, they nurse underwater, they're not very good on land. A hippo is a good example of perhaps what a transitional form might be like for a whale. Or a hippo could just stay a hippo. So, but anyway, we have the complete fossil record, or a very complete fossil record of the evolution of whales. Okay, now, these are predictions that evolution has made, but evolution also makes what I call retrodictions. That is, Darwin was very big on this. You can find features in biology that were puzzling to biologists that only make sense in the light of evolution. And as soon as you realize that things evolved, suddenly everything makes sense, whereas before it was a puzzle. Darwin devoted 2 chapters in The Origin of Species to embryology, the development of plants and animals. And one example that he gives is one like this, which is the embryology of the spotted dolphin. Dolphins are like whales. They have front limbs. They came from the land originally. They kept their front limbs, but they evolved into flippers. They lost their hind limbs and just developed a tail which has no bones in it. But if you look at a whale embryo, and this is the spotted dolphin at 24 days, you see something very unusual. You see that it has this hind limb bud forming, which is exactly analogous to the hind limb bud of every other creature that does develop hind limbs. This is a human embryo at 30 days, and you can see it has this same bud here. This one develops into the leg. This one was once developing into the leg, but it starts off, and the same genes are working in both of these legs. Hand 2 and sonic hedgehog are 2 of the genes, and you can see they're active in both of them. But if you follow the human embryo, you'll see that this thing, this doesn't work very well, that this forelimb bud develops into our arms, the rear limb bud develops into our legs. If you follow the development of the spotted dolphin, however, from 24 days to 48 days, that hind limb bud goes away. It just vanishes. Okay, and eventually we're left with a dolphin that has front limbs and no hind limbs at all, just a tail. Why on earth, I would ask a creationist, would God start developing legs in a dolphin and then remove them? Okay, there's no answer for that that makes sense. The answer is that these animals evolved from animals that did have hind legs. They start to develop them in embryos for reasons that I could talk about later. We're not sure about that. The developmental program begins, but then it aborts. Okay, there's no other explanation for this developmental program except that these animals evolved from animals that had 4 legs that were useful on land, and then they lost the last 2 of them. Sometimes, however, you get a dolphin that's developmentally challenged, I guess you'd call it these days. It actually, through some developmental accident, develops hind limbs. So if you see, very rarely, and that's why this dolphin is being pointed at and held at by divers, you get a dolphin that has rear legs. And if you cut those things open, you'd find out that it has bones in it. It has a rudimentary femur, tibia, and fibula. Okay. And what other explanation is there than this animal contains genes in its DNA for the developmental legs, but those genes in general have been silenced? That's what it looks like. We go through the same process. If you look at a human embryo at the age of 6 months, and we all did this, it's covered with this coat of hair called the lanugo. This is a premature infant at 6 months. I think you can see the coat of hair over it. And every one of us had a thick coat of hair when we were about 6 months of old age. And if we're born prematurely at 6 months, the baby comes out looking like a sort of little chimpanzee or gorilla. And the parents are freaked out, right? But the hair drops off. And it drops off in utero in most of us at about 6 months of age. Why is it there? Why do we bother to grow this coat of hair and then get rid of it before we're born? Well, ask a creationist. It can't be because to keep us warm, because we're floating in a bath of warm fluid at 98.6 degrees or 37 degrees Celsius. We don't need hair. Moreover, hair doesn't work to keep you warm when you're wet anyway. What this is, and it's the same genes that evolve in the chimpanzee, is the coat of hair that we inherited from our ancestor, which starts to form, but like the hind limb of the spotted dolphin, it disappears before we're born. That is, this is an ancestral remnant, a vestigial feature of our ancestry that goes away before we're born. And a lot of my students will come back to me 20 years later and say, well, I don't remember anything you taught me, Dr. Coyne, but I do remember that I had a coat of hair when I was 6 months old. So, and that's a good thing to remember, because it's good evidence for evolution. There you go. If you look at a whale skeleton in a museum, I'm sure there's one of these in Zagreb, you can see that there are these vestigial bones that tend to hang down from the skeleton. They're connected by wires because they're not connected to the rest of the skeleton. If you look at these things closely, you'll see they're the remnants of the legs that the whale used to have, just like those little Basilosaurus legs that were 30 centimeters long. Sometimes the development will go askew, like in the humpback whale, and you'll get something that looks like a leg. This is those bones. This is 1 foot, so this whole thing is about 1 meter long, and it has the tibia, the tarsus, and the metatarsus. So sometimes the developmental program will actually go askew and reproduce the ancestral features of the organism, showing that it still has the genes for those features in the DNA. Okay, here's another retrodiction. Actually, sorry, this is a prediction. It was a prediction that was made only 10 years ago. It was based on looking at a human embryo at an early stage of development. So there's a human embryo at 4 weeks old. There it is. You can see it has this balloon connected to its belly. But you can see it's an empty balloon because you can see right through it. What is this thing? Does anybody know? It doesn't do anything. Anybody guess?
Yolk.
It's a yolk sac, okay? This is the remnant of the yolk sac that our ancestors had when they were reptiles and amphibians. We don't have a yolk sac because we don't get nourished from yolk. We're nourished through the placenta. Nevertheless, and early in development, we still develop a sac that could contain yolk, but it doesn't. It's empty. It's just an empty balloon. From this, geneticists predicted, well, maybe if we have the yolk sac, maybe we still have the genes for egg yolk in our genome, even though we don't make egg yolk. After all, evolution doesn't get rid of features by simply pulling the genes out of the DNA. There's no way for that to happen. It simply silences the genes that it doesn't need anymore. So maybe there are some remnants of egg yolk genes in our DNA. And so 10 years ago, when the human genome was sequenced, yolk sac, they found 3 genes in the human genome for egg yolk. They're dead. They don't do anything. They've been rendered impotent by mutations, but they're still there. How do you explain to a creationist why we still have these genes that could make egg yolk, but they don't? Its only explanation is that we descended from animals that had egg yolks. And there's lots of other genes we have in our DNA. Our DNA is a graveyard of dead genes that were active in our ancestors. For example, genes for making vitamin C We and the guinea pig are the only animals that do not make vitamin C. God knows why the guinea pig doesn't. We don't need to make it because we get it from our diet, but you can see that we still have every gene necessary for the synthesis of this vitamin, except the last one has a mutation in it that makes it inactive. Otherwise, we could make vitamin C. Why are they still there? Because we inherited the pathway from our ancestors. We have lots of genes for smelling, olfactory receptor genes, that have been rendered useless by mutations. Probably 30 to 40% of our genes for detecting odors are gone. We're a species that depends on auditory and visual stimuli instead of sniffing, but we still have a lot of dead genes that in a dog or a cat are still active in helping them smell. How do you explain these things unless we were descended from organisms that were olfactory organisms? Okay. Well, I'll probably go a little bit over. So we'll just go over two other areas that are evidence for evolution. One of them is biogeography, the distribution of plants and animals on the surface of the globe. This is the subject of another 2 chapters in Darwin's Origin, and there are features of life on the planet which can only be explained by evolution. I'll just take one of them. This is the nature of life on oceanic islands. Oceanic islands are islands that rose out of the sea without any life on them, like the Galapagos. This island, Lord Howe, which is about 16 square kilometers. Hawaii is on their series of volcanic islands. When those were produced, there was no life on them, or so the geologists tell us. This is Lord Howe. It's between New Zealand and Australia. If you look at the life on oceanic islands compared to what we call continental islands like Sri Lanka or Great Britain, you find a very different kind of life, very different series of life. Oceanic islands like Lord Howe do not have any native amphibians, reptiles, mammals, or freshwater fish. You will not find anything on this island or on Hawaii, maybe one native mammal, which is a bat, or the Galapagos, which has no native mammals. It has a few native reptiles, but they can swim, like the land iguana. Why is that? If you look at Great Britain and Sri Lanka, they have lots of these animals. Okay, so why the difference between continental islands, which were connected to continents, and oceanic islands, which were connected to the oceans? Well, a creationist could say God didn't put amphibians, reptiles, or animals on these islands because they couldn't live there. And the Lord, in his providential wisdom, does not put animals in a place where they can't survive. Well, Darwin recognized this potential objection, and he answered it very well by saying, well, what happens if humans put animals on these islands? They happen to do very well. In fact, if you introduce mammals or amphibians or freshwater fish to islands like Lord Howe or Hawaii or the Galapagos, they take over. These are 2 of the animals that are taking over Hawaii right now, the mongoose and the cane toad, which are eating all the native fauna and birds. So they do very well. It's not that the God didn't put them there because they wouldn't thrive. It's probably that they never got there in the first place. And there's very good reasons why mammals, fish, amphibians, and reptiles cannot cross huge expanses of water. What you do see on islands like Lord Howe are plants, birds, and insects. Lots of them. Why? Because these are the animals and plants that could get there by flying. And for birds, they poop out seeds that they eat on land. Most of the plants on islands like Lord Howe are actually pooped out by birds rather than floating there in the ocean. And insects and birds can fly to these islands and then evolve once they're there. So this was Darwin's explanation for the nature of the difference between oceanic and continental islands, by a combination of dispersal and evolution. There's no other way to explain this pattern except by evolution. And I've never seen a creationist try to explain this pattern. They just keep their mouths shut when they're confronted with it. By the way, the animals and plants on Lord Howe happen to be most similar, though not identical, to the nearest mainlands, New Zealand, New Caledonia, and Australia. And that again supposes that those migrants come from the nearest mainland, they land on these remote islands, and they evolve in isolation. And that explains why there's certain kinds of animals on islands and plants, and why it's missing other plants. The chance of an amphibian making it from Australia to Lord Howe is 0, because if you put a frog in salt water, it's going to be dead within a minute. Same thing with a freshwater fish or a reptile or a mammal. There's no way they can get there. Okay? What about natural selection? Somebody asked me last night, do we see natural selection in action? We should, if evolution is true, because it's number 5 of the points. And the answer is yes, we can. Although natural selection is very slow and it's hard to see it operating in nature, We have at least 300 cases now of well-documented natural selection. A lot of these were in the 1986 book by John Endler called Natural Selection in the Wild. He has just a big list, I think it's called Table 2, which covers most of the book of examples of biologists watching natural selection operating in animals. The most famous example, which you may know of, is the evolution of the beak and the medium groundfinch, Geospiza fortis, on the Galapagos. In a matter of 1 year, because there was a drought, only the largest finches were able to survive because the ones that had the big beaks could eat the big seeds. All the small plants died. The small finches that had small beaks couldn't eat the big seeds. You could actually find dead birds all over the island. Within 1 generation, that beak size changed by 10%. That's natural selection. Well understood, well observed, and it's very rapid. So it's not always completely gradual. A 10% change in 1 generation is very fast evolution. Okay. But you know, that's the kind of evolution you have to have if you're going to see it with your own eyes. The last example I want to give is bad design. Natural selection predicts that in order to get from one step to another, each transitional stage has to be adaptive. It has to increase your reproductive. So you can't, it's not like a designer sitting down at the drawing board and drawing the best possible organism. You have to start with a well-adapted organism and get to a better adapted organism. It's like making a better car, designing it while it's still running on the road. You have to have an organism that is still adapted and living in the wild while it's evolving. And so you would predict that therefore the design of many organisms would not be a perfect design. It wouldn't be optimal the way a designer would design it. It would be the best you could do given evolution. Here's my favorite example, the prostate gland of humans, males, humans. The prostate gland, how many of you know what it is? If you're a male, you surely know what it is. It's the gland that produces the liquid in your sperm. It happens to surround the urethra, which is the tube through which your urine passes. Okay? If you're an older male, and you may have seen this on television, those prostate gland tends to swell like that, and it tends to collapse this collapsible tube. And if you watch American television, I don't know if it's true in Croatian television, but you'll see lots of ads of old men on the golf course suddenly running off to the bathroom because they have to go really bad, and that's because they can't pee, because their urethra is squeezed by their enlarged prostate gland. Now this is a really, really bad design, to put a collapsible tube running through an organ that's prone to swelling. I mean, that's really something no designer would do. Robin Williams in a movie said, this is like running a sewage system through a playground. Okay. But the reason it is like this is because the prostate gland evolved from the walls of the urethra, and we know this from development. So we have what was possible for us to have. It's not the best possible design, but it's the design that happened to evolve. Okay. So, and we have lots of bad design. Our wisdom teeth, our bad backs, you know, all of you can think of features that you have. How many of you have had a bad back or thrown your back out sometime in your life? Well, not most of you. I certainly have. It's because our muscles have not yet adapted to our vertical posture, because we used to walk like this. Now we walk like this, but our muscles haven't caught up yet to our new posture. Okay, so that's pretty much the evidence for evolution. So let me just summarize it for you. First of all, from the fossil record, we see change, splitting, and transitional forms. We have vestigial organs and genes, like the yolk proteins in humans. We have quirks of development, like the transitory coat of hair on our body, the lanugo. We have bad design, like the prostate gland or the wisdom teeth. By the way, if you go to look at the Neanderthal fossils, you'll see they had a much bigger jaw than we did. They had plenty of space for their teeth. We evolved a smaller jaw, but we still have those teeth, and that's why our wisdom teeth get crowded and sometimes have to be pulled. Biogeography is more evidence for evolution, dispersal followed by evolution. Examples of natural selection in real time. All of these go together to show that evolution is true because they demonstrate all the 5 steps of evolution. Evolution itself, gradual change, splitting, common ancestry, and natural selection. Okay, and notice that these are all from different fields of biology. Paleontology, morphology, embryology, biogeography, the study of distribution of plants and animals, and examples of natural selection in real time. These are all different areas of biology. This is what's called consilience. We have all this different evidence from different areas coming together to point to one theory, which is the theory of evolution. And this shows that the theory of evolution is true in the sense I talked for before. You would be considered foolish or extremely religious, maybe they're the same thing, if you if you, I can't control myself sometimes, I'm sorry, if it's true. Okay. Nevertheless, evolution is disprovable. There are certain observations you could make to show it to be wrong. I'm not going to go through these because I'm at the end of my talk now. But here's 12 here's some of them. Fossils in the wrong place. If you found a human fossil, say 2 billion years ago in the fossil record, that would cast serious doubt on the theory of evolution. If you found an adaptation in one species that was only good for another species, natural selection can't create such an adaptation, then Darwinism would be in severe doubt. But we don't see any of this. In fact, none of these observations have been made. So Darwin, despite a million chances for evolution to be proven wrong, it has never been proven wrong. It's always comes up right. That is as close to an absolute truth as you can get in science. And I'll finish with a sort of depressing figure. So I hope I've convinced you that there is not just one line of evidence for evolution. There are many, many lines of evidence for evolution from many, many areas of biology. And despite that evidence, Americans continue to reject it obstinately and persistently. If you survey Americans, 63% of them believe in the existence of angels, not just metaphorical angels, but literal angels with wings that are flying around somewhere. 19% accept evolution. We have plenty of evidence for the theory on the right. We have zero evidence for the theory on the left. Nevertheless, look at the difference in the degree of belief and certainty that accrues to this. And as I said last night, if you ask an American, if you have a fact which flies in the face of your religious beliefs, what would you do? 64% of Americans, nearly 2 in 3, would reject the fact that goes against their religious belief, rather than reject their religious belief. And this, ladies and gentlemen, and brothers and sisters, as Christopher Hitchens would say, is the reason why Americans do not accept all the facts that I've adduced here. And if you want to read about this conflict between faith and fact, I talked about it last night. It's available in this book. And thank you very much. Thank you.
Thank you very much, Professor Coyne. And now the favorite part of lecture for Professor Coyne are your questions. So,
shout them out loud. And
these questions
make
Professor Coyne happy.
Yeah. By the way, I don't speak Croatian, and I apologize for that, so you have to ask in English.
I'm a layman in the field, so I wonder how that branches which you pointed out towards reptiles and birds occurred, because birds are warm-blooded, whereas reptiles are not. So what was crucial for them? Was it the heart that changed?
That's a good, so you're saying what were the evolutionary forces that caused the evolution of warm-bloodedness? We don't know, except that we know that the earliest, there is evidence, and Bob Bacher, I was going to say Bob Trivers, but Bob Bacher has shown that there are certain features of dinosaurs that suggest that dinosaurs were already on their way to becoming warm-blooded. There are certain advantages to being warm-blooded. If you've ever watched a turtle, for example, and I see them every day on the pond outside my office, they are limited in their activities by the temperature, because when it gets cold, they simply can't move. So you can see that if you had an ability to warm up your own blood somehow through metabolism or whatever, that it would enable you to remain active for a longer period, perhaps get more food, perhaps find a mate. So, I mean, I don't know the answer to your question. All I can say is there are conceivable advantages to being warm-blooded, mainly a longer period of activity, which might have been the selective pressures that led to homeothermy. But again, so often in evolutionary biology, we weren't there, so all we could do is speculate. But actually, we can find evidence that some reptiles that might have been the ancestors of mammals had rudimentary features of some ability to heat their own bodies. So, up in the back, loud, please.
Okay, so a big part of the presentation, same as your presentation yesterday, was kind of mocking the U.S. For believing that much in some superstitions and religions and not much in evolution. But still, the U.S. has a lot of science, one of the best scientists in the world, Nobel Prizes and everything. Okay, we don't have to discuss that. You talked about it yesterday. But what would you say are the consequences for the U.S.
I didn't quite hear him. Maybe you could reprise the question for me. So
how come that the United States, which has such developed science and a lot of investments into science, have such disproportionate number of people who still disbelieve evolution?
Okay.
And what are the what are the consequences? What are the bad effects of not believing in evolution?
Okay, so that's a good question. I think I answered the first part of it in my talk. Why are Americans so resistant to evolution? Because we're the most religious first world country in the world, except for maybe Turkey, if you consider a first world country. And a lot of Americans simply are Christians, the same people who elected Donald Trump, Christians who are resistant to science, and so they just reject evolution outright. So that's why America does that. Now, what are the bad consequences of rejecting evolution? There's several of them. First of all, you cut yourself off. I mean, in terms of practical consequences, there aren't many. I cannot pretend that understanding evolution is going to make you rich or healthy or smart. There are not many practical consequences of evolutionary biology, except perhaps for predicting the next flu vaccine that's going to happen, or how animals are going to adapt to pesticides or stuff. The advantage of understanding evolution is that it opens up to you a whole new vista on life. And that's an intellectual and a spiritual experience, which I think should be open to everybody. So when you look at when you go to the zoo and you see a chimpanzee and you say, well, that's my nearest relative, you get feelings that you don't get if you're religious and you just say, well, God made this and God made me, and that's the end of that. So that's one thing. And the other thing is the advantages that I listed at the beginning. It enables you to be able, if you deny evolution, then you're denying evidence. And so those Americans who don't believe in evolution develop the habit of not accepting evidence, not just for evolution, but for things like global warming, vaccination, and things like that. So one of the advantages of accepting evolution is to develop a scientific, naturalistic, evidence-based view of the world. And that plays out in many, many areas, including politics and other areas of science that don't have anything to do with evolution. So, yeah.
Speak up, speak up.
Yeah.
Try to yell, like.
Or you can ask in Croatian.
Professor Coyne, please.
Yeah.
In your lecture, you mentioned 5 points of evolution.
Yes.
Evolutionary change, gradualism, speciation, common ancestry, and
Natural selection. So you get a B. Okay.
you mentioned a 6th one, so non-selective mechanisms of evolutionary change. Why do you actually?
I didn't quite get that. My hearing is not very good. I have to understand. So did you get the question? You might ask it in Croatian. He could translate it. So.
Whoops. So in the book is 6 principles of evolution. Here is only 5.
What does it say? What's the other one in the book?
Non-selective mechanisms.
Non-selective mechanisms.
Oh, I don't think that's the principle. Yeah, I don't think that's principle number 6. But as I mentioned in the talk, there are other processes of evolution that can cause genetic change in populations, like meiotic drive, that's an arcane one, or genetic drift. So I didn't mean to, what I was talking about is the 5 major tenets of neo-Darwinian evolution. There are other propositions as well. I don't think in the book it says 6, but I'd be willing to be wrong, and I would still accept that.
At least in creation, translation is 6.
Oh, then I would blame Pavel for that.
The English version.
Okay, well then that's
English version, not creation. English.
Okay. So, but that's okay.
Version have 5.
There's a lot of other aspects of evolutionary theory that I couldn't talk to. I was just distilling it down to the 5 major contentions. Yes.
Can in biological species a phenomenon which is the least probable be the most common?
Sorry, what is the? Yeah.
Which is the least probable, a phenomenon which is the least probable, can it be the most common one in biological species?
Well, I'm not sure what you're asking.
The least probable is most common.
Probable and yet the most common.
So, like humans are the least probable and most common. That's the. No,
I said in biological species.
Okay. In biological species.
Can there be a phenomenon which is the least probable and yet the most common?
I need a tangible example, not a philosophical example.
Least probable and most probable.
I can't answer that question unless I understand it. I'm sorry. Yeah, we'll move on, I guess.
The example relates to the distribution of protein families in the sequence genome.
The distribution of what?
Protein families.
What about them?
Unfortunately, we didn't hear from you about the novelties discovered in the sequence genomes. Today we have data of about over 100,000 genomes have been sequenced of different species. And in these genomes, scientists have discovered a huge amount of novelty. A huge amount
So novelty
of
genes, like
genes
you
and
sequence the
proteins.
genomes,
Yeah.
and when you sequence the genomes, you find the novel genes inside the genomes.
You find what genes inside?
Novel genes. The novel
Yeah,
genes.
yeah.
Origin orphan genes.
Yeah, so?
So it's common.
What's your question?
No question.
I can't see your figure from here.
Okay, I will pass it to you. So the distribution of protein families follows the power law.
You have a distribution of phenomena, earthquake lengths.
There are several other phenomena which show the same distribution.
Yeah, I don't understand your question. If you're, are you attacking?
There is a question. Is there a question?
Yeah, there is a question.
Okay.
Very big question. Because the group of proteins which show no homology in sequence with any other proteins is always the biggest group in the sequence genomes. So-called singletons or orphan genes or taxonomically sticky genes.
Orphan genes are the biggest group in genomes.
I don't understand your question. We should move on to somebody else.
Actually, no.
Oh, let me ask you a question. If you're denying evolution, let me ask you a question. Oh, you know, I shouldn't ask him a question.
Yeah, okay.
No, maybe it's too complex for the auditorium.
Yeah, okay. Yeah. Let's go up. Next.
Organisms, right? How about evolution of primordial cell? Is there any evidence for it?
How does a primordial cell evolve? Are you asking me that? Well, we weren't there, of course. So if you're asking me to give an exact explanation of where the cell came from, I'm going to say we don't know. Now, you might say, well, therefore God did it. But I don't think that's a set. Sorry? I can tell you, what I can tell you is that we know that the primordial eukaryotic cell, that is the true cell that comprises multicellular organisms, came from the ingestion of a bacteria by another bacteria, which created the mitochondrion, and to get plants, the ingestion of chloroplasts. But in terms of how life started, we don't understand how it did. And all I can say in response to that question is, we don't know yet, but I predict that in the lifetime of my children, if I had any children, we will be able to recreate life in the laboratory under primitive Earth conditions. And then those, let me finish. And then I would say that
Cyanide is the primordial chemical compound which is important.
what
Yeah, but
I should just let you guys answer.
latest things in the origin of life are hydrothermal vents, right? Inside the ocean, lost cities and black smokers and biochemistry that's happening near the hydrothermal vents, and you have flow of the energy, water of course, catalytic stones. So there are very good papers in like 5 or 6 years that explain how jump-starting the life in chemistry to biology.
Yeah, I would add, you get one question. Sorry, you've had your say. One question. I would add.
Let's go here and speak up, please. You can. I'm sure that you can speak louder than.
Real loud.
No, it's not loud. Come on, you're a man. You can do it. Come on.
Women too.
Yeah, but what about architects?
What about what?
Architects.
Is it
Oh, what about it?
Is it a transitional form, or
is it a transitional form? Archaeopteryx is probably, it lived at about 100 million years ago. It's not thought to be ancestral to modern birds, but it was a reptile-like bird. So, I mean, birds, there wasn't a straight line from reptile to birds, but everything developed. There was all kinds of the branches, and some of them went extinct, just like the horses. And Archaeopteryx is probably one of those bird-like lizards or bird-like dinosaurs that went extinct. We're not absolutely sure about that, but it's certainly a transitional form in that it shows that at a certain period of time, about 100 million years ago, we had things that were both dinosaur-like and feathered at the same time. But we know Archaeopteryx shows up later than we have more modern birds, so it probably was not an ancestor of modern birds.
This one, I'm a high school student, third year, and I have a feeling that a lot of my classmates and friends do not actually have a problem with evolution itself, but rather on, like, I don't know how to tell in English, abiogenesis.
Oh, you mean the origin of life?
Yeah.
Yes.
Because they don't, they show them their skulls and bones and geological evidence. They seem to believe, and then they don't reject that. But when you say that a bunch of molecules, organic molecules, formed into amino acids and prokaryotic cells in the future, they just don't. Yeah, they don't buy it.
Yeah, that was.
When I get into the discussion, because I was a Seventh-day Adventist myself, alone, or when I was young and stupid. Now I'm good. Coming out. And when I get to the discussion, I do not have evidences for that. I even asked my professor. She didn't know what to say, like strong evidence which will support abiogenesis.
Yeah, and the answer is we don't know. Now, Damian said that we have good theories about how it happened. One of the ones he cited was in the hot smokers, the hydrothermal vents. You can get chemicals concentrated sufficiently that perhaps early proteins could form, and we can find evidence for that. There's also cold vents in the Atlantic Ocean that could have been, and if you read Nick Lane's new book on that, he gives a scenario for the origin of life. But the best way to answer that is, well, we don't know yet. Does that mean that God did it? If the people say that God did it, then you say, okay, what's your evidence that God made the first cell? Because they don't have any evidence for that either. All they have is a book that says, what? I mean, the best answer in science you could give when you don't know something is to say, I don't know, but we're working on it. But certainly after we have early life, then there is no doubt that evolution occurred. So all those people have to take the position that God made the first cell and then Darwin took over after that. And that just doesn't make any sense. Also in light of the fact that you ask them what their theory is for abiogenesis, and they're going to say something like, God did it. And you could say, okay, what's your evidence that God did it? And they're going to either wave the Bible or they're going to have to say what we say. I don't know. I don't know how he did it. The fact is that as scientists, we might be able to get the answer. Because as I said, I think within 50 to 100 years, under the conditions of early life in the laboratory, we will be able to produce life. Not just artificially by putting amino acids together, but under early life conditions. When we do that, then the whole objection to abiogenesis being divine will go away. If we can just show that science can do it, then you can no longer make a credible argument that science can't do it and therefore God must have done it.
I just wanted to point out that this is the weakest point in this discussion for me, and I just wanted to ask you for advice, and thank you.
Yeah, well, let me just say one more thing. To say that we don't understand something is not a weak point. It just means we don't understand.
It's the weakest point for me in the discussion.
Yeah, no, but you're absolutely right, though. I mean, a lot of people consider this to be, like that gentleman up there, as a severe weakness in the theory of evolution, that we cannot explain how life started. I mean, we have some theories about it, and I think in 50 to 100 years we'll have better theories and maybe even be able to create life. But as of right now, we don't know. But think about 200 years ago. We didn't know a lot of things that we know today. I mean, things like lightning, how magnets work, how the planets stayed in their orbits. where disease came from, those were all thought to be inexplicable by natural processes, and therefore people said God did it. And one by one, these things have fallen to science, and we no longer need to invoke the divine. And I'm absolutely certain, not in my lifetime, but in a couple hundred years, that the origin of life will be another thing that falls to science, and we don't need to invoke the divine.
Next question.
Jeste li možda zašto stvari ljudima toliko teško prihvatiti evoluciju u odnosu na kreacionizam? Zašto je lakše prihvatiti anđele, a ne teoriju evolucije?
So why is easier to accept angels than theory of evolution for people, for humans? Why it's easier to believe in creation?
Because easy. That's an easy one. Because when you're a child, you're taught that there are angels from when you first go to church. You're not taught Darwin until you're like, if at all, until you're 16 or 17 years old. So you already get propagandized towards believing in angels from the very early part of your life. Also, it's easier to just say, well, there's angels than there is to understand the theory of evolution. I just lectured for an hour on the evidence for evolution, and I still could not get anywhere close to a complete explanation of it. So it's no surprise that people find religious explanations which are somewhat intuitive and easier to grasp, and you get propagandized with them when you're a child than it is that something that's more complicated like Darwinism. But Darwinism happens to be true. We have evidence for evolution. I just gave an hour lecture on it. Nobody's ever seen an angel, at least not somebody that's not insane.
Htjela bih pitati, jeste li možda primijetili razliku u odnosu prema evoluciji i kreacionizmu u odnosu na vjere? Znači, recimo, židovska vjera, kršćani.
Basically, we didn't notice the amount of creationism in different religions. In Islam, more about it. Yeah, isn't there any difference between the religions?
Oh, yeah, absolutely, absolutely. I mean, for example, Islam. Islam is, in general, because most Muslims tend to read the Quran literally, and there's a creation story in there, Islam is one of the most resistant religions to accepting evolution. In fact, I could not get my book translated into Arabic. I'm still trying to, but nobody wants to do it. Orthodox Jews don't believe in evolution. Jehovah's Witnesses don't believe in evolution. There's lots of religions that don't. Southern Baptists, even in the United States, lots of Protestant sects don't believe in evolution. The Catholic Church, and I have to say this, says they accept evolution, but they don't really. They accept some of evolution, but they insist that Adam and Eve are the ancestors of all humans, as I said yesterday. They insist that we have a soul, so their view of evolution only goes from the neck down. And I call that a sort of diluted, it's theistic evolution. So the Catholic Church is one of the most liberal churches in accepting evolution, but it still can't go all the way to doing it. Yes?
There's another question here.
Oh, okay, sure.
I've seen a great video.
Yes.
I've seen a great video from Ken Miller explaining human evolution from apes. And there is this, he explained that how the reason why there are 24 pairs of chromosomes in great apes, and there are 23 of us. Probably you've seen that one too.
Yes, the fusion.
And one thing I didn't understand, maybe it's in the book, I haven't read it in Croatian yet. We know from our experience that usually two species that are very closely related but have a different number of chromosomes create infertile offspring. How is it that this first specimen of with 23 pairs of chromosomes were able to create?
Yeah, this is a rather arcane point which I cover in my genetics classes. Chimpanzees, our closest relatives, have 24 pairs of chromosomes, and we have 23 because we fused two of the chromosomes together. So here's chimp and human. And what's happened in our evolution from the chimpanzees is these two things have fused together into, and we have two chromosomes, so here we have, well, say 24 pairs, here we have 23. His question is, how do you go from here to here if the intermediate condition, which is having one of these and one of these, is infertile? And the answer is it's not infertile. When I do this in the laboratory, for example, with Drosophila, these pair up very nicely, like that. And this is a fertile organism. And so what happens is if this mates with another one, then you can go from this state to this state because this just mates with itself. And all of a sudden, and these are fertile, and you get this, which is Homo sapiens. So the claim that it's, you know, that these intermediate stages aren't fertile is not an accurate claim. These are called fusions and fissions, and we understand them very well.
I'm going to try to ask a question now. So we talked a lot about evolution of morphology and new species, but there's also something else that's been influenced by evolution, and that's something that doesn't leave fossil record, and that's behavior.
Yes.
In animals and presumably in humans. And there's also a problem with accepting that, because you addressed this with a couple of examples.
Yeah. Igor's talking about evolutionary psychology, which is the discipline that's concerned with the evolution of the human brain and the behaviors that humans evolve. It's a relatively new field. It started, I guess, with sociobiology in the 1970s. I just basically talked about morphology, but there's a whole field that talks about human behavior. Unfortunately, behavior doesn't fossilize, so it's much more difficult for us to understand human behavior. But there is certainly parts of our behavior, in fact, probably quite a lot of it, that is remnants of, or is evolved behavior in the same way that our bodies have evolved. It would be foolish to think that this part of our body, this part of our being evolved through natural selection, but this part did not. And you can make predictions, for example, about human behavior that are met from evolutionary theory. One of the predictions is that we will behave like other animals, like other mammals, and that males will tend to want to copulate with everything, whereas females will be picky in general. And that's the way it is in the animal kingdom. Sperm is cheap, eggs are expensive. Females are selected to be very careful about who they mate with. Males, sperm costs nothing, you want to mate with everything. That's the best way to spread your genes. So that's one of the predictions that you can get. And you look at human behavior, you can do tests of this. And what they do is they send college students out into the campus, good-looking men and good-looking women, and they ask them, will you sleep with me tonight? You know, 0% of the women will answer that question yes. 100% of the men will answer that question. No, sorry, 0% of the women will say no, will reject the male. 100% of the men will say yes. And this has been repeated over and over again. Human sexual behavior is one of the great examples of how we show our evolutionary past in our behavior. And everybody knows this to be true, but a lot of people reject it because it's not politically correct. A lot of people think men and women are exactly equal in all respects, and therefore they cannot behave differently. Even if we have this annoying data, we'll explain it as a result of culture instead of evolution. But that's awkward because we happen to do exactly what every other animal does, which is the males are profligate and the females are picky. And there's many other examples of human behaviors that comport exactly with what we expect evolution to do. The problem, of course, is that we have culture, and so somebody can always say, well, it's just all culture, not evolution. So it's easy to dismiss it, even if it is true. And we don't have the fossil record of behavior that we do, for example, for the horses. So we have to make predictions and inferences, and it's a very difficult field, but it's a field which is eminently worthwhile, and I think Igor studies that field. So it's worthwhile reading some books on evolutionary psychology. So.
Yeah, but also we men always say yes because we want to make ladies happy, and we are kind, so we say yes.
Well, that's, yeah, I mean, there are alternative theories, but we behave exactly the same way.
You had a question.
I had a question, but it's kind of answered. I was once confronted with an argument that I couldn't say much more about variability, and we couldn't know what kind of a natural selection force would be on. But that's the intro to the question of, in science we make inference, but we also make predictions.
Yes.
And evolutionary theory is so good in delineating everything that happened in the past, but how come we can't make predictions?
But I just gave you some predictions.
Yeah, well, that's what I wanted to say.
Okay.
Apart from behavior, would you be able to shed some more, I don't know, insights and predictions on another?
Like in future, what will happen in the
Yes.
Oh, you mean how we're going to evolve? That's a difficult question because it depends on what mutations are going to occur and how the environment is going to change. So here's one prediction that I can make that has been fulfilled. When AIDS started appearing in Africa and people started dying of the HIV virus, you could predict that humans would gradually evolve genes that would make them resistant to the AIDS virus. Okay, and that's exactly what happens. There's a form of an immunology gene that has spread because of AIDS. Okay, now that's not really, I mean, maybe that doesn't excite you. But if
it's also more prevalent in Scandinavia.
In Saudi Arabia?
Scandinavia.
Oh, in Scandinavia.
Prevalent in Scandinavia. So wouldn't that mean that it would have evolved in Africa?
Sorry, genes for resistance.
Yes, HIV-1, it's more prevalent in Scandinavian countries.
Well, I can't.
Scandinavians have
I would have to see the data. I can't accept what you're telling me at face value. All I can say is, like, you gave me you wanted an example of a prediction. I gave you one. Now you're saying, oh, there's some data here that don't quite fit that prediction. I don't know if that data is true or not, but I gave you an example of prediction. Here's another prediction. If we introduce antibiotics for a new disease, a new infection, that bacteria or the virus will become immune to the antibiotic. And it happens over and over and over again. It's a prime example of an evolutionary prediction. It's very few antibiotics have failed to cause the evolution of resistance in microbes. So that's, you know, over and over again we see that. Artificial selection is another example. It's not natural selection, but we can do anything we want to an animal by throwing anything we want at it. So, you know, I can predict, for example, that if I take an African wildcat, I could turn it into something this big by artificial selection. That's what we did with dogs. Nobody's done it with cats yet, for obvious reasons. You don't want a pet cat that's this big, for obvious reasons. But I would predict that you could do that. So that's a prediction I've made that has not yet been tested. So.
If I might chip in, there's a great book by Lee which came out on the project of domesticating the fox, and it's a Russian lab that's been doing this for a couple of decades now, and they've basically been artificially selecting fox and making them more friendly to humans, and now they basically made dogs out of foxes within our lifetime, just by carefully picking the ones that, as pups, react better to humans, and then breeding them again and again and again, and making a behaviorally another species out of that animal. There's a great book by Lee on that right now.
Okay. So if evolution is true, then it should be in principle possible to turn a reptile into a bird or a chimpanzee into a man if we would have sufficient information and technology, which we now have. So we have the sequences of the organisms and we have the gene editing tools to do this. So could you imagine an experiment? Okay, this is ethically debatable, but if you would know the genes which you should modify, could you start with the chimpanzee and turn it into a transition species?
Into a what species?
Into a what species? I'm sorry. Yeah.
So you know reptile birds. Can you do it vice versa? And chimpanzee know the data set of chimpanzee genome, and then you do mutations into chimpanzee.
Yeah, I mean, people are trying to do that, right? They're trying to make extinct animals by altering the genome of like the elephant genome to make the woolly mammoth come back again.
It's been an ultimate proof that evolution is true.
Well, I just proved, but you don't accept the data I gave you? I mean, how much more do you need?
I think he wants to make mating of chimpanzee and human and simple.
Yeah, well, I could prove it to you. Just say, I'll give me the chimpanzee genome, give me the human genome. I'll just say, okay, you change that G to a T, you change that A to a C, and you're going to get a chimp. You don't even have to do it. You can just say, well, you know, this is the chimp genome, there's the human genome. If we do this genetic modification, we're going to get one from the other. But I would argue that, you know, there's already enough evidence for evolution that you're asking for overkill. I mean, you know, and if we can't...
is actually why not do it and make ultimate proof.
Well, people are trying to do that now. I mean, they're trying to turn the elephant into a woolly mammoth. They're kind of doing it in a weird way because they're not changing the whole genome. They're just putting a few genes in. What they're going to get is a hairy elephant with long tusks, but it's still an elephant. But you could get something that looks like a woolly mammoth. I don't know if that would satisfy your desires or not, but we could basically, as Darwin said in The Origin of Species, breeders commonly think of animals as being infinitely plastic, that we can mold them as we want to by selecting on their variations. And sure enough, as Igor implied, we took the wolf and we turned it into a Chihuahua, we turned it into a Dachshund, we turned it into a German Shepherd, we turned it into every breed of dog that's there by using a model of natural selection, artificial selection. If we can turn a wolf into a Chihuahua, then it's no big deal to turn a chimpanzee into a human. That's all I can say. You know?
Yeah, basically evolution asks for very unethical lab practices to make ultimate goods. Okay, so here was the question. You had a question at the very beginning. You still want to ask that question? Yeah.
Yes.
Yeah.
I wanted to ask about consciousness. When does an evolutional scale comes that into play?
Some consciousness on this scale when it comes into play, the consciousness.
Well,
there is that matter and what comes consciousness.
Good question. I mean, are dogs conscious? I think they are. If you kick them, they will. So you're going to tell me?
Yes.
Okay, are dogs conscious?
Yes.
How about worms?
Yes.
No?
Yes.
So what about amoeba?
Yes, also.
So everything is conscious.
Not everything.
Well,
matter is not conscious.
Sorry?
Matter is not conscious.
Sure. So during somehow, so I would
just must come consciousness into.
Well, first of all, how do you know that a worm is conscious? How do you know that a worm thinks I am a worm?
If you put a finger and starts to pull him, he will start to move. So there is.
Yeah, but that's not consciousness in the way we think of them. That's a
definition of consciousness. Then.
A consciousness is qualia, in my definition. It's the subjective sensation of feeling pain, of thinking of yourself as an entity, and we don't know if worms have that. In fact, there's a famous paper by Tom Nagel called "What Is It Like to Be a Bat?" And he claimed that we would never know how other animals, how conscious other animals are. I mean, we don't know if a worm feels pain. We can poke a worm and it will draw away. But that doesn't mean that it feels subjective pain the way we do. It could be an automatic reflex that is evolutionarily built into that worm, that when you poke it, it goes away. And that has nothing to do with consciousness at all. So,
by our definition.
Sorry?
By our definition, not.
Well, that's my definition of consciousness.
Okay.
You know,
so there is a definition that consciousness is a symptom of life. If something is moving, then it is conscious.
Well, then consciousness came in when things started to move.
So it's my question. There is a common source, common ancestor.
No. No, I mean, you're giving me your answer.
I'm not saying, I'm asking.
No, 4 million years. No.
4 billion. 4 billion years ago, common ancestor. He's the first.
Yeah?
Do you agree?
Yes, probably about 4 billion years.
Before him, what was there?
Chemicals?
And that chemicals at one point, they become him.
Become humans.
It's
Eventually.
not him.
Yeah, so what?
That we are interested. I'm interested.
Oh, if you're asking me when consciousness evolved, it depends on your definition of consciousness. If your definition of consciousness is when something moves, then I would say, well, then consciousness began when the first creature moved. And I don't know when that is. My definition of consciousness is when we have subjective sensations of pain, of pleasure, of ourselves as individual organisms. And the answer to that is I don't know. Because I think that I'm pretty sure that Damian is conscious because he would tell me that. And I think other humans are conscious. I think my cat is probably conscious because when I kick it, it gives a very similar pain reaction to humans. But I'm not so sure that a worm is conscious in that sense. I don't kick my cat. I said, no, I don't even have a cat. I was just making that up. So.
What is the situation in non-Abrahamic religions?
Sorry?
What is the situation in the second stage of evolution for the non-Abrahamic religions, like not for Christianity or Muslim countries, but about, let's say, Buddhism, Hinduism, and so on? Do you have any data on it?
Question?
Acceptance of religion in non-Abrahamic religions.
What about it?
Of evolution, compared to Abrahamic religions.
Oh, yeah, I just sort of answered that question a minute ago. Compare the acceptance of evolution in Abrahamic versus non-Abrahamic religions. It's all over the map. Some Abrahamic religions accept evolution. Catholicism has a limited acceptance of evolution. secular or Reformed Jews accept evolution, but there are Christians that don't, like Southern Baptists or Jehovah's Witnesses. So, you know, some religions have no problem with evolution, some of them do, and I don't think it has any correlation with a particular kind of religion like Christianity. All I can say is that Islam in general tends to reject evolution, but there are a lot of Muslims that accept evolution too. So,
yeah, but what is with the non-Abrahamic religions? Like in Japan, like Buddhism,
not Abrahamic religions,
non-Abrahamic.
Yeah, well, I presume you consider Hinduism a non-Abrahamic religion. Some Hindus accept evolution and some of them don't. I mean, Hinduism is a very diverse religion. I mean, a lot of them reject evolution. I mean, the Indian government now is anti-evolution, and they're strict Hindu, the BJP. But there are lots of Hindus, and I met them in India, who accept evolution. So it's not the religion. Hinduism has no monolithic center like the Vatican. So you can't say, does Hinduism accept evolution or not? You have to ask, do Hindus accept evolution or not? And some of them do and some of them don't. I'm not sure exactly what the proportion is. People don't take polls in India that would tell you that. Thanks.
Okay, since the world will stay on youngers, our young friend here in the last row, the question is,
are maybe viruses linked between chemical and biological evolution?
Sorry?
Are viruses linked between chemical and biological evolution?
What is the difference between them? There is.
Are they like missing link? Are they
viruses between
the transitional form
between chemical evolution? Yeah, there's actually, it's a very good question. Clearly, life evolved from chemicals. And when you define when life started, depends on what you mean by life. So what's clear is that we had a continuum between chemical evolution and biological evolution. And there's really not a distinction between those things. The more stable chemicals, the ones that were able to replicate, were the ones that persisted, and eventually those things developed into replicators and into cells. And there is some point in between the chemicals replicating themselves and cells replicating themselves where you have chemical evolution turning into biological evolution. And that depends on when you say life begins, because there's no hard and fast definition of life that is adhered to by all biologists. But there's a new book by Addie Pross in Oxford University Press, which takes up exactly this question. It's P-R-O-S-S, which actually talks about how chemical evolution becomes biological evolution. And I'd recommend that you read that book. It's designed for the layperson. So.
Okay, so I know you have a lot of questions and you will have an opportunity tomorrow to ask more questions on the last lecture, which is called No, You Don't Have a Free Will. So I ask you all to come tomorrow and show that you have a free will by showing at the lecture.